Hello everyone, myself Divyansh Arekar. Today we study the concept of Sutherland Hodgman algorithm, which comes under the 2D polygon clipping. So first we'll study what is clipping. Clipping is the process of removing parts of polygon that are outside a viewing window. In this, we only want to render what's visible on the screen to save processing power. In simpler words, when we want to clip any shape to be fit into specific boundaries to save our machine power is known as clipping. This concept is majorly concerned with two things: subject polygon and clipping window. Subject polygon means the shape which we want to clip, and the clipping window is the area on which we have to clip the shape. Next, Sutherland Hodgman algorithm has a major core concept, one edge at a time. When Sutherland and Hodgman were making a method for polygon clipping, which was very complex and tedious task, so they decided to do divide and conquer. They decided one edge at a time, which means they will clip a polygon against one edge at a time, then make a pipeline like they first clip the polygon against left edge, then the right edge, then the top edge, then the bottom edge, which makes the task very simpler than the other methods which are used to do polygon clipping. There are four stages of clipping a polygon. Stage 1 is against the left edge. When we clip a polygon against the left edge is at x minimum. Then we clip against the right edge which is at the x maximum. Then the bottom edge which is at the y minimum, and then the fourth stage is at the top which is at y maximum. These are the four stages by which we clip a polygon. There are four key rules of polygon clipping in Sutherland-Hodgman algorithm. We have to remember these rules thoroughly. It says the case 1, when the line goes from inside to inside, we have to keep the endpoint as the name of a line. Second case, when inside to outside, like E to A, we have to keep the name of intersection, like here the intersection will be I and the endpoint will be removed. Third case, when outside to outside, when the line is like here, we'll let it go. It's a garbage. Now, the fourth case, outside to inside, when the line comes from outside to inside, we name the intersection like here B to A, we name the intersection as B dash, and the inside will be remain as it is. Now we'll see how our algorithm works. What are the steps involved in Sutherland-Hodgman polygon clipping algorithm? So we'll take an example. Here we have in polygon and a window something like this. And we have to clip our polygon to fit into our window. So here we start from a top edge. We have to clip the line S4 to S3, which is cutting our top edge. So the line is going from outside to inside and then outside. So we'll name the intersection point, this intersection point, as I2. And then we move to the right edge. Now in the right edge, the polygon is not even touching it. So we'll remain it is as it is. Now the fourth step, the bottom. Even in this, the polygon is not even touching it. So we'll move to the next step. Now the left side, this side, the polygon is touching this three times: S1 to S2, S2 to S3, and S3 to I1, I2. Now first we'll see S1 to S2. Here the line is going from inside to outside or outside to inside. We'll name this intersection point as I6, and we'll garbage the S1 value and remain the S2 value. Now the second, S2 to S3. The S3 will be removed and the intersection point will be named as I5. Third, S3 to I2. Same, the S3 will be removed and the intersection point will be named as I4. So we have named our intersection point as I4, I5 and I6. After the clipping polygon, it was a very simple method. Sutherland Hodgman polygon clipping algorithm is the one of the simplest process of clipping. Now, after all these clipping, we got our result. This polygon will be completely fitted into our window. Now, we'll see some advantages and disadvantages of our algorithm. The advantages are fast, efficient and simple, easy to implement in hardware using pipelines, using a one edge at a time rule. Third, clipping any subject polygon and fit into our window. It can clip any type of polygon. But there are some disadvantages, which are the clip window must be convex. If the window is concave, there will be some issues like it can degenerate edges while clipping a concave subject polygon. Degenerate means the edge which we are clipping on concave window can be distorted, can be self-overlapped, or can sometimes can have zero length. So there will be some major issues with concave subject, but it works perfectly on convex subject polygons. With this, we have completed our topic, Sutherland Hodgman Polygon Clipping Algorithm. Thank you.